outdoor air pollution is increasing the allergenicity of the world in which we live. So there was this amazing study that the US Department of Agriculture did. They planted ragweed in the inner city of Baltimore, in a suburb, and out in the countryside, 40 miles away. The inner city urban ragweed plants grew twice as big as the rural plants and produced 5 times as much pollen. At the beginning of the 20th century, hardly anybody had allergies. Today, there are 1 billion people in the world with allergies. It's at least 30%. And the US government data on this indicates that over half of Americans will experience an allergic reaction during their lifetime.
Hey guys, welcome back to High Intensity Health Radio. We're in front of Dr. Leo Galland's office. We're going to talk about his new book, The Allergy Solution, which he authored with his son, Jonathan Galland. It's loaded with great information. I know the interview is going to be jam-packed with cutting-edge insights about how you can reduce inflammation in your body, boost the health of your microbiome, and cut back allergies, asthma, and other inflammatory conditions. So let's go talk to Dr. Galland.
What I've been interested in for a while has really been 2 things. One is inflammation. That's been something that I've been researching and dealing with clinically for a long time, and realizing that inflammation is not just what everybody thinks of as inflammation, classically, like arthritis or an obvious inflammatory disorder that is really known now in the integrative medicine community. Inflammation plays an important role in all sorts of chronic ailments. So that's something that's been a major area of interest for me. And the other thing that's been a major area of interest for me clinically is just dealing with people with mysterious illnesses. I mean, people come to see me from everywhere, literally, and they've mostly been to see a lot of other docs, and they've been given various diagnoses, and the question is like, what's going on? Why, what's happening? So those 2 things have converged in this work, The Allergy Solution. Now, of course, along the way, I realized that a lot of the inflammation we were seeing and a lot of the mystery ailments that I was seeing had an allergic basis or origin. And the allergies could be molds or foods in particular. Sure, I would see people with asthma or eczema or hay fever who had more conventional kinds of allergens acting as triggers. But the mystery illnesses, it was the molds and the food. And in working with these patients, the question that would come up was always, why are you allergic? And I realized that if I had patients who knew they had allergies, their allergists were trying to figure out, what are you allergic to so you can avoid it, or what drugs can we give you to suppress the symptoms? But I would get focused on the question of, well, why does this person have so many allergies? What is the source of the immune dysregulation and the inflammation that's going on? And there would basically be 2 major kinds of factors. One were environmental factors, and fundamentally toxicity, and the other was a problem in their gut. And especially if they had a lot of food allergies, there was always a problem in the gut. And we needed to address the gut problems in order to help the food allergies. So it was those 2 areas, the environmental toxicity and the gut problems, that became mainstays of my practice. And then along with that, there was the impact of nutrition on allergy, because a lot of my patients with any kind of chronic inflammation are deficient in certain minerals in particular, or essential fats. And one of the earliest areas that I started reporting on were essential fats and the omega-3s and the omega-3, omega-6 balance and the importance of that for health. And that goes back like 35 years. And then the work on the gut in allergy and inflammation goes back 25 to 30 years. And the work with magnesium and zinc, which are key minerals also in that same period of time. So when I started to work on the Allergy Solution as a book, which initially was a self-help book, which it is. I mean, it's fundamentally a self-help book. But I started approaching it as a self-help book to take the work that I was doing clinically in my practice and make it and translate it into something that a person could do that on their own. Mm-hmm. I realized that I really needed to deal with the allergy epidemic as a phenomenon. And my son Jonathan, who was writing the book with me, did a lot of the research on the broader aspects of why is there an allergy epidemic. Right. We worked on this together. And that actually is a pretty fascinating story. And in a sense, I discovered stuff that I'd known all along, but I saw it with a clarity that I hadn't really quite grasped.
You mean like the research helped to put the pieces in the puzzle?
Yeah, and that's happened every time I've written a book. And you start writing a book, and you've written a book, so you probably have the same experience. It causes you to really organize your thinking, because you're trying to explain something to a reader who's never going to meet you. So you try to organize your thoughts in a way that someone else can understand, and with no give and take. You're not looking at that person's face and saying, oh, they're not getting what I'm saying, so let me say it a different way. And when you do that, it really helps you understand what you already know with such a greater level of depth that it can be transformative for you as an author, not just for the reader. So this is what I discovered and put together as we were creating this book. Number one, the allergy epidemic is a huge phenomenon, and it's more profound than I think any of us ever really realized. Before the late 19th century, there was no concept of allergy in medicine. I mean, it just didn't exist. You don't find it in any of the old medical texts. Maybe there's a description of anaphylaxis to a bee sting, but that's about it. That's the extent of it. And then hay fever starts to emerge. Now, hay fever is not an easy thing to miss if there's a lot of hay fever. So clearly, there wasn't hay fever until the 50s, until the late 19th century. And then it started to increase. And it slowly and steadily increased throughout the 20th century. And then asthma, which had been recognized in the past and which was not always allergic, started to really increase from about the 1960s onward. And there was obviously an epidemic of asthma. And the third wave of this epidemic has been food allergy. And what's amazing is that anaphylactic type food allergy to nuts among children in the US and in England tripled between, let's say, 1995 and 2010. So there's been this massive increase. At the beginning of the 20th century, hardly anybody had allergies. Today, there are 1 billion people in the world with allergies.
I mean, it's 20%, is that right?
It's more. Well, it depends on what country. In the U.S., it's at least 30%. And the U.S. government data on this indicates that over half of Americans will experience an allergic reaction during their lifetime. 56%, I think. And what the U.S. government has been doing since the late 60s is conducting these periodic surveys, the National Health and Nutrition Surveys. And in the course of doing that, they've looked at a lot of different kinds of data, and they've been doing skin tests. The rate of allergic positivity on skin tests has gone from about 10% to 50% in the past 40 to 50 years. And yeah, at least 30% of the population in this country has allergies that are active. And around the world, it may be 20% in some places, 10% in other places, 30% in I mean, in New York, almost everybody has allergies.
Yeah.
When I presented my data at the Integrative Health Symposium last month, 50% of the people, of the health professionals there, at least, raised their, had allergies. So it's become the new normal. Mm-hmm. You walk around this city, you talk to people, everybody's got allergies. And certainly everyone knows lots of people with allergies. And it's the spring, and the spring is really a time when people start to think about their allergies and become aware of it. So the question is, why is this happening? Now, one of the explanations that has been advanced is the so-called hygiene hypothesis. I think it's really wrong. And the strongest evidence against the correctness of the hygiene hypothesis is that the highest rates and most severest allergic reactivity in the US is found in the inner cities. The rate of skin test reactivity and the severity of eczema increases with poverty, dilapidated housing, and the presence of garbage in the streets. How does the hygiene hypothesis even begin to explain that? Mm-hmm. The only aspect of the hygiene hypothesis that has any connection to reality is the understanding of the gut microbiome and the way that's been destroyed by modern living. And that I think is really evidence-based and is proven. But otherwise, in order to really adhere to the hygiene hypothesis, you have to ignore all the other data that we uncovered. And so what I realized is that the allergy epidemic is the result of the changing environments in which we live, and there are 3 levels of environment that matter, and the impact of nutrition on each of those levels. So here's the rundown on it. We'll start with the external environment. Okay, that's the one that we all share. That's the one that is contributing to climate change and global warming. Outdoor pollution, industrial and automotive, is one factor driving the allergy epidemic. And it's driving it in 2 ways. Part of that is this particulate air pollution in particular damages our respiratory tract. And so the inflammation that it generates just allows us to be more sensitive to allergens. But the other part of it, and it may have to do with the air pollution, but it has to do with the carbon dioxide levels, that outdoor air pollution is increasing the allergenicity of the world in which we live. So there was this amazing study that the U.S. Department of Agriculture did. They planted ragweed in the inner city of Baltimore, in a suburb, and out in the countryside, 40 miles away. The inner city urban ragweed plants grew twice as big as the rural plants and produced 5 times as much pollen. The suburban plants were intermediate. Now, here's the thing about pollen that is not widely understood. Pollen is toxic. Pollen is not just something that plants are using to propagate themselves. Pollen grains, and especially ragweed, but also grass pollen, contains an enzyme called NOx, N-O-X, which stands for NADPH oxidase. It's a potent oxidative enzyme. It generates free radicals. It's part of the immune response when your body is fighting bacteria. Your white blood cells generate NADH oxidase to help kill the bacteria. So the NOx enzyme in the pollen, when it alights in your nose, it starts producing damage in your nose.
Even if you have a healthy microbiome and all else.
Yeah, we haven't gotten to the gut microbiome. Now, it may be that the nasal microbiome interacts with that, and I'll get into the nasal microbiome in a couple of minutes, because this is this incredibly fascinating tapestry of interacting factors, which I found to be, the more I studied it, the more amazing it was. It was like analyzing a work of art by Monet, looking at, or Van Gogh. When you look at a Van Gogh painting, now I'm just going to digress here for a minute, and you stand as close to that painting as Van Gogh would have had to have been to do it, you don't see anything. All you see are splashes of color. It's like, how did this guy know that if you step 10 feet back from the painting, there's a real beautiful picture? Because when you're as close as he had to be, you don't see any forms. You just see these colors. This is a little bit the same way. When you get into it, there's, wow, this is really interesting, and that's really interesting. That's pretty wild. You step back from it 10 feet, and this pattern emerges that is very consistent. It's very clear. And I'll get to summarizing that at the end of this little, at the end of this explanation. So,
it sounds like pollen is almost a defense mechanism against environmental toxins. Is that what you're saying a little bit?
Well, the plants actually, the plants, I think, so this is the other aspect of pollen. Most of the allergens in pollens are defense proteins that the plants make when they're under stress. So, we don't think about, the plants in our environment are stressed. Yeah, I mean, we're stressed and they're stressed. And when they're stressed, not only do they make more pollen for whatever reason, maybe it's because because if plants had a brain and could worry about the survival of their species, they're thinking, hey, we better be making more plants. Or for whatever reason, they're making more pollen, and the pollen is more allergenic because they're making more of these defense proteins, which are called pan-allergens. And they're not only found in pollen, they're found in plant foods, in fact. So as our food-bearing plants get stressed, they're making more of these pan-allergens. So basically, we're polluting the world, and it is making our world more allergenic. In fact, and it's not just pollen-producing plants. Poison ivy, this is a study done at Duke University. If you grow poison ivy in a polluted environment, it produces more of the allergen that creates the contact dermatitis. So, the future of the world, it's not a barren desert. It's going to be overgrown with allergenic plants and vines, and everybody will be coughing and sneezing and wheezing. I mean, that's one aspect of it. The second aspect is the indoor environment. We spend 90% of our time indoors. There are over 100,000 chemicals that we have introduced into our indoor environment. And the number keeps going up. Every 2.6 seconds, there is a new chemical that comes out of a laboratory someplace in the world. It's about 1 million a year. And I mean, for the most part, we have no idea what these things are doing. Now, we do know something about some of the indoor chemicals. Formaldehyde, which you'd mentioned before, is the best understood from an allergic perspective. Now, formaldehyde is actually not a xenobiotic. It's a natural substance that in trace amounts is produced in your body. But it's also, higher amounts are very toxic. It's a carcinogen. It's the basis for embalming fluid, but it's used to stiffen fabric, so it's in new clothing. It off-gases from carpeting, even wool carpeting off-gases formaldehyde. It's used to make particle board and pressed wood products, and so, which is a major source of indoor formaldehyde. So we've introduced formaldehyde into our environments. Of course, cigarette smoke releases it, wood smoke releases it, latex paint releases it. So these researchers in Australia at Monash University studied the levels of formaldehyde in homes. And they found formaldehyde in bedrooms, in living rooms, and in kitchens. And there was a direct relationship between the level of formaldehyde in the home and the likelihood that children growing up in that home would be allergic. And at the highest levels, it was associated with asthma. And researchers at University of Arizona confirmed the formaldehyde asthma link. And I think formaldehyde is working as an irritant. It can be an allergen itself. It also dysregulates the immune system. And that's just one out of thousands of substances. And there is one that we can relate back to the microbiome, and I had promised something about the nasal microbiome. Right. Okay, so there's this antibacterial called triclosan. Triclosan is used in antibacterial soaps and shampoos and dishwashing detergent and all sorts of cleaning products, even in gym clothes. You know those gym clothes that don't smell? Mm-hmm. They have triclosan in them. Now, when your skin touches triclosan, it's absorbed and it travels throughout your body. So these researchers at the University of Michigan measured the levels of triclosan in nasal secretions in the nose. 50% of the people they tested had triclosan in their nose. Wow. And that's a pretty, to me, that was astonishing. Half of a random population in the US has triclosan in their nose. I mean, what level of exposure does that represent? And what triclosan does, even though it's supposed to be antibacterial, it changes the microbiome in the nose, but not in the way that you would think. Triclosan actually increases the ability of dangerous bacteria, Staphylococcus, to attach to human cells. If you expose mice to triclosan, they're more susceptible to staph infections. So you have, and what the Michigan researchers found was, you have triclosan in your nose, you have a greater growth of staph in your nose. Now, here's the thing about staph. You see, and this is the way you keep following. And I don't think anyone has ever put all of this stuff together. But this is kind of what I've been doing for 40 years, is finding data and looking at patterns. And it's a process of induction. That is, you go from the small pieces of information to the large pieces, to seeing the whole pattern. Then you go to the deductive part, which is you apply the large pattern to individual patients. And it really works. I mean, it's what's guided my practice. So what does staph do? Well, one thing it can do is it can cause infections. It's a major cause of sinus infections. But it does something else related to allergy that's really interesting. Staph releases, or it creates and then secretes, these proteins called superantigens. And if you're making them in your nose and sinuses, they're in the mucus and you swallow them and they travel down your GI tract. Superantigens screw up your immune system. They dysregulate it. They, in particular, inactivate a group of white blood cells called regulatory T cells, or Tregs. Now, one of the main jobs of Tregs is to keep your immune system in check, to regulate it, that's why they're called regulatory cells, and keep it from overreacting. People with allergies have defective Treg cells, so that these staph toxins that you're swallowing, because you used a triclosan containing dish detergent that got into your body and went to your nose and increased the amount of staph, they are now making you allergic to food. And just one example of how this actually plays out clinically, because this is not just theoretical. People who have nasal polyps, and nasal polyps are associated with chronic nasal allergies and inflammation and sinus infections. People who have chronic rhinitis, which is nasal inflammation, and sinusitis, sinus inflammation with nasal polyps, they have a very high rate of food allergy. These are studies done in Europe. No one in the US has actually looked at this. But in Europe, where they've studied it, 70% of them had ordinary IgE type allergic reactions, nothing esoteric, to foods that they were eating. In fact, they were more allergic to foods than to environmental allergens, where there was about 50%. Well, nasal polyps are associated with staph. And that's well known. People who have nasal polyps have higher levels of staph growing in their nose. So, so here we expand the link a little bit. Triclosan, staph, nasal polyps, food allergy. And it goes in that order. The food allergy is actually, you could trace it back to the triclosan. So there's a study that was done at the University of Maryland with children, and they measured the level of triclosan in their urine. And there was a direct relationship between the level of triclosan in the urine and the likelihood that those kids would have allergies. Okay.
Really fascinating stuff. I want to pause right there because I think it's really important that a lot of people, if they were to read that study, they would associate the triclosan with the reduced bacterial diversity, but we're saying it's affecting Staph aureus, and Staph aureus make the superantigens that suppresses the Treg cells. So you're introducing a whole new concept because a lot of practitioners, Dr. Galland, still don't really have a good grasp on the Treg cells, and I like how you explain that. So that's a really important finding.
Yes, I think it is really important. And I'll get to the nutritional aspects of it because that's where that's where an important part of the solution lies. Sure. So then going into the microbiome, lack of diversity of microbes in your gut, in your respiratory tract, in your nasal mucosa, that is highly associated with allergy. What hasn't been looked at enough by the scientists is what's been called the mycobiome. That is the fungal part of the microbiome. But the researchers are looking at that now, and they're finding that at the same time that the bacterial diversity is shrinking, the fungal organisms are taking over. Well, hell, we've known about that for decades, integrative practitioners. But now the scientists are really finding, and interestingly, there's a rheumatologist in the city who NYU is doing a study of, has been doing an ongoing study of gut microbes in arthritis. And so about 6 years ago when they were setting this up, this very well-known rheumatologist called me up and he said, "We'd like you to refer some patients to us for this study." And he said, "We're beginning to realize that you were always right." I love hearing that. These notions that I've been working with for decades are really started to move into the mainstream, especially in the area of the microbiome research. The microbes living in your body have a profound effect on your immune system. For one thing, 2/3 of your immune system is located in your gut. And those immune cells, the gut is kind of like the training center for your immune system. It's boot camp. And those lymphocytes in your gut that are learning from sampling the antigens from the food and knowing what the microbes are like, and they're being influenced by the microbes, they circulate throughout your body. They go to different organs, they communicate information, they come back to the gut. So the gut is really where the immune system gets most of its information and learns how to respond, especially in infancy when we're most susceptible to this. So factors like the antibacterials that we're exposed to, but also the antibiotics. 80% of the antibiotics that are used in this country are used in animal feed. They're not even given to people. And, so you're ingesting them if you're not eating organic food. And then herbicides and pesticides, they don't just kill pests or herbs, they kill bacteria. And we'll take the most notorious, which is glyphosate, Roundup. And the whole problem with GMO foods. The problem with GMO foods is not some kind of theoretical thing about, it's not good to change the genes of foods. Maybe it's good, maybe it's bad, but the fact is that this is not, the GMO foods are not being developed out of a totally benign reasons. they're being developed to make agricultural farming, industrial agriculture easier and more profitable. So these foods are being developed. Monsanto has developed these foods to be resistant to Roundup. So then all that the industrial the industrial organization needs to do is spray all the fields with Roundup, and the soybeans will grow up, and and you won't have to weed the fields. Well, yeah, right. So the effect of that is that all of this food is now contaminated with glyphosate. And glyphosate is an antibiotic. In fact, Monsanto has registered it as an antibiotic. And studies done in poultry have shown that when you feed chickens glyphosate, food that has glyphosate in it, it really screws up their gut microbes, and it encourages the growth of harmful bacteria. And one of the points about the microbiome that I think really needs to be emphasized is it's not just about diversity. And you can't just go in there and say, okay, we're going to increase diversity. There is a powerful interaction with inflammation. And I mean, the research shows this very clearly, but you hardly see it in the discussions. Inflammation changes the microbiome. When you get inflammation, one of the chemicals that's released is nitric oxide. It's an important part of the inflammatory cascade. I mean, you need nitric oxide. At low levels, it's essential for circulation and the health of blood vessels. But with inflammation, you get more nitric oxide. That creates a buildup of nitrates in tissues. And nitrates encourage the growth of certain bacteria and discourage the growth of other bacteria. Now, it just so happens that the bacteria that love nitrates are bacteria like E. coli and other bacteria in this family that contain most of the human pathogens. These bacteria are very smart. They know how to be human pathogens. In fact, they thrive on adrenaline. So when you're under stress, your E. coli thrives. And so we know that like stress, for example, increases the risk of infection. Well, it does that in part because what it does to us, but it also in part because what it does to the bacteria in our bodies. And that part of it, what the stress is doing to the bacteria is not really well appreciated. But there's this whole research field called microbial endocrinology, the effect of our hormones on bacteria and the bacteria on our hormones. Okay, so E. coli and related bacteria promote inflammation. Now, from the bacteria's point of view, that makes a lot of sense. You're a bacteria that likes to grow in a nitrate-rich environment. Well, you're going to do everything you can to get your host to give you a nitrate-rich environment, right? So you get this vicious cycle that occurs. And just giving probiotics is not going to solve the problem. You have to deal with the pathogenic bacteria. You have to get them out of there. That's why sometimes antibiotics actually work better than probiotics for restoring a healthy gut flora. I mean, it's a very tricky balance, and you have to really, you got to walk on both legs. It's like walking a tightrope. You got to get the right balance. Philippe Petit,
This is a really novel concept. So it's a bidirectional communication system, and basically the bacteria, what you're saying is making the host environment more hospitable for itself by driving inflammation.
Right. So you have to deal with the bad bacteria, not just try to build up the good bacteria. And you really have to deal with the inflammation. Whatever is driving that inflammation, you have to deal with it. Because if you don't deal with the inflammation, you will never get good diversity of bacteria.
Wow, that's profound.
Okay, so that's why allergies become really important, because even if the allergies are not the main cause of what's going on, once you start to become allergic, now you've got all this allergic inflammation, which is aggravating the problem, and you have to deal with that. You have to eliminate the allergy-causing foods, for example. That's why I developed this technique called the power wash, which was a way of getting rid of allergenic foods, introducing a lot of anti-inflammatory foods at the same time that have a low risk of being allergenic, and also foods that help regulatory T cells and help their function. Okay, so now we're at the level of food. Okay.
I had a question about the food. So onions and garlic were off the list. And I was kind of curious on that because Russ Jaffe and others we've interviewed.
Yeah, we'll get to onions and garlic eventually. Yeah. They're not actually green onions. The green part of the onions are on there. Reason I left onions and garlic out initially in the power wash is that there are a lot of people who are sensitive to onions and garlic. And there are two levels of sensitivity. See, onions and garlic, some people are allergic to them, but more importantly, they contain fructans. Fructans are polymers of fructose. And there are a lot of people who have difficulty digesting fructans and absorbing the fructose that comes out of the digestion of the fructans. And so that's going to dysregulate the gut bacteria. So we're not going to start out with onions and garlic. I mean, I love them, and eventually when you move on to what I call the full immune balanced diet, yeah, they play an important role. But I chose foods to begin with that do not have fructans, that are not highly fermentable, that are not going to disrupt the gut microbiome in unpredictable ways, and that are hypoallergenic. And also that contain nutrients that are not only potent antioxidants, but that support and protect regulatory T cells. So I had to make a lot of choices in doing that, and I narrowed it down to a handful of foods. And this isn't something you do forever. This is a 3-day process. And I chose 3 days because I figured, well, you can do this on a long weekend, and you can jumpstart the whole process with a soup, a smoothie, and oolong tea, and I chose oolong for a particular reason, and then you start introducing foods, and it's a process that I call re-entry. As you start introducing the foods in a systematic fashion, you begin to learn what you're sensitive to, what your body doesn't like, what's fine with your body, and then from that basis you can construct for yourself the diet that is optimal for you. Because it isn't the same for everybody. But there are some principles that I think are universal. And they not only deal with regulatory T cells, but with how your body is protected from all of this environmental toxicity. Okay, so that's where it's kind of like we loop back now with nutrition to protect you. And here's what the data shows. I'm just picking up some key points here. Sure. Outdoor air pollution. The most protective aspects. Now, I'm just going to say something in general. In general, vegetables and fruits are the foods that protect against allergies and against the development of allergies, and to some extent omega-3 fatty acids. But when they've done epidemiologic studies or treatment studies, increasing fruit and vegetable consumption significantly protects. And omega-3s also are protective. High dietary magnesium, which you get from nuts and seeds and vegetables, is protective. Selenium is protective from seafood and nuts, especially Brazil nuts. So those are factors that protect against allergy in general. And when it comes to outdoor air pollution, the most protective factors are those found in broccoli and other brassica vegetables. And there's this amazing study from UCLA that I cite. What?
I think John Rydell, he does a lot of allergy research. I think I've noticed.
Right. They, they gave broccoli sprouts to people with allergies. But first they exposed them to diesel exhaust particles. And then they exposed them to their allergens. And the diesel exhaust really aggravated. I mean, it was so toxic, it really aggravated the allergic responses. And it was the level of diesel exhaust that you might encounter if you walked under an overpass in Los Angeles. Okay, I mean, it was not elaborate. It was an ambient level that you would,
People are exposed to all the...
Yeah, right. And then they fed these people broccoli sprouts. Within 3 days, the broccoli sprouts blocked the ability of the diesel exhaust to aggravate the allergic reactions, and it seemed to do so by enhancing detoxification. It was the sulforaphane and related substances in the brassica family vegetables that was doing it. So including those in a healthy diet is really important. The thing with broccoli is you have to eat it raw, because if you cook it, you kill the enzyme that creates the sulforaphane. Or you can cook it the way I have people do in the soup, in the power wash. But then you need daikon radish, which we add at the end of the soup, uncooked, which tastes really good. It's nice, has a really nice flavor. But the daikon radish has the enzyme myrosinase that converts the precursor of sulforaphane into sulforaphane. Okay, so that's one aspect in which foods are protective. Take the indoor toxins. Bioflavonoids inactivate staph toxins.
Oh, wow.
So if you're eating a diet that's rich in bioflavonoids from herbs, spices, teas, and fruits and vegetables, then even if you've got staph growing in your nose, the staph toxins are not going to have such an easy time making you more allergic. But if you're eating a kind of like typical American diet, which is pretty low in flavonoids, then there's nothing to block the staph toxins. And then of course there's the effects of food on the microbiome. Flavonoids actually encourage diversity of gut bacteria. The more rich in flavonoids, because they regulate growth of bacteria. So the greater diversity of flavonoids that you have in your food, the greater diversity of bacteria that you're going to have growing in your gut. And fiber is important, but it's not just fiber. You can't just say, okay, well, I'm going to take a lot of fiber, that's going to do it. You really need a total dietary approach that is rich in different kinds of fiber and many different kinds of flavonoids. Okay, so I said this was going to be in a nutshell. I mean, this is a pretty big nut, but that's basically what we realized, and that was the basis for the program that we developed.
Yeah, it's really fascinating. So let's kind of zoom in a little bit more on some of the teas that you mentioned, and connect the flavonoids with the T regulatory cells and any other foods or supplements that you found in your clinical practice to kind of boost the activity of immune tolerance and T regulatory.
Okay, sure. And let me just tell you a little story about T regs. Sure. I think it's in the book, but this was research done in Scandinavia. They took kids who had milk allergy, and they would get different symptoms, runny nose, itching, abdominal pain, diarrhea. And so they put them on a total dairy-free diet for 6 months. And at the end of 6 months, they had them test out milk again. And half of the kids had outgrown their milk allergy, and the other half hadn't. The only difference immunologically between the two groups was that the kids that had outgrown their allergy had a much higher T regulatory cell response when they were challenged with milk. So that the milk challenge didn't cause the allergy because the T regs got active when they saw the milk. That's what you want your T regs to be doing. You want your T regs to be out there saying, ooh, here's a dangerous reaction. We don't need it. Let's calm it down. So what T regs need in order to grow well and to function well are several things. First of all, they need folates, folic acid. Folic acid is not a term I like to use, although that's what's out in the, in the vernacular, in the common language. Folic acid is not a vitamin. It's a synthetic pre-vitamin that was created because it was cheap and stable. But the fact is, people vary greatly in the rate at which they're able to convert the folic acid into the natural reduced folates that are the ones that your immune system needs and that your T regs need. Some people can only convert 2% of folic acid into reduced folates. And the part that you don't convert can be toxic and can actually impair immune function. So you can't rely on a vitamin pill with folic acid in it. You need reduced folates. and they're not very stable, so I like to get them from food. And there are a number of vegetables that are good sources, spinach, and cooking may destroy some, so even though beans are very high in them, you cook the beans enough, you don't really know what you're getting. Raw spinach is a great source. Arugula, avocado, a lot of green, leafy greens are good sources. So that's why I created this green smoothie, because we would get plenty of natural folates produced, and you make it fresh, so the stuff doesn't deteriorate.
Right.
Okay. Vitamin A is important for the development of Treg cells. And you can get all the vitamin A that you need from fruits and vegetables in the form of beta carotene or alpha carotene. These are converted into vitamin A. You could go for animal sources, but then, if you have too much, there's a potential for toxicity, which you don't get with the plant sources.
Like liver and stuff, you don't recommend animal liver periodically?
Well, the problem is liver is where all the toxins go. So how do you know that you've got an animal with a really clean liver? It's like the notion that you should eat dirt. Well, yeah, it depends on where the dirt is from. I wouldn't want to eat any dirt any place close to New York City. So how do you know what this animal's history is? So sure, you can get it from liver, you can get it from egg yolk, but the safest sources are plant sources. And for there, you need to cook them, because the beta and alpha carotene are best absorbed from cooked vegetables, and you need some oil and fat to absorb them. So I think that's an important component, and that's why in the immune balance soup we've got a lot of there are carrots and broccoli and a lot of vegetables that are rich sources of the carotenoids that build up your vitamin A. And then there are flavonoids. And flavonoids help the function and the development of Treg cells. And there are 3 particular flavonoids that are important. So there are 3 particular flavonoids that are important in terms of individual flavonoids. One is fisetin. Fisetin is found mostly in strawberries. That's the richest source. And fisetin has been shown to protect T regulatory cells from the effects of stress. So, you have allergies, you have a stressful environment for your Tregs. Strawberries are really helpful. Fisetin also is neuroprotective. It protects the brain. They've been researching it at the Salk Institute. And I've created a smoothie with a lot of strawberries and high in fisetin to protect the brain of people with neurodegenerative disorders like Parkinson's disease, and created that with the help of a colleague of mine. So we have strawberries as a source of fisetin in the smoothie, in the immune balance smoothie. Then there's apigenin. Apigenin, the richest sources of that is parsley. I love parsley. In fact, the combination of the green part of scallions and parsley, it's so delicious. I love to use it on all sorts of foods. So we've got a lot of parsley in the immune balance soup as a source of apigenin. And then there's EGCG from green tea and oolong tea. Turns out that oolong tea has as much EGCG, which is epigallocatechin gallate, it's a flavonoid, as does green tea.
Without the caffeine though, right? The oolong doesn't have quite as much.
No, there's a little bit of caffeine. You can easily decaffeinate tea yourself. It's because caffeine comes out in hot water very rapidly, whereas to really extract the catechins and the other flavonoids, you have to boil the water for several minutes. So what I have people do, if they're caffeine sensitive, is you take the tea, you steep it in hot water for 30 seconds, discard the water, then you boil it for 5 minutes. So you get the caffeine out, but you still maintain the EGCG and the other catechins that you need. Oolong tea actually has even more of an anti-allergic effect than green tea in animal studies with rats and mice and in clinical studies with humans. It takes about the amount of oolong tea you'd get from 10 grams of tea leaves, which is 4 or 5 tea bags a day, to get that effect. And this has been studied in Japan in people with eczema that had not responded to standard medical treatment. So that's why oolong is a favorite tea. But green is pretty good, and I use green tea in the smoothie and have it really boiled well to get the EGCG into the smoothie. Wow. So those are really the three major types of flavonoids that are important for anti-allergic T regulatory effects. Of course, there's quercetin, which is found in onions and in apples, and there are a lot of supplements of that, which may have a direct antihistaminic effect. But I'm not primarily looking for symptom suppression. I mean, there are drugs that do symptom suppression. Sure, if you can do it naturally, that's fine, but that's not where the revolution is. The revolution is in changing the immune system.
It's beautiful. I think a lot of patients and a lot of practitioners, even in the natural space, are looking for natural symptom suppression. You know, there's a lot of the quercetin and NAC out there, and folks are kind of, I think, missing the big picture of what the allergy, symptoms are telling us about the overall immune system. So I love your approach for that matter.
That is really an important point. So I've been talking all the time, but the symptoms of allergy are fundamentally ways of your body ridding itself of a toxin. I mean, you sneeze, you cough, the airways constrict so you're not breathing in the air that's out there. You scratch, you get diarrhea or you vomit. I mean, those are protective responses. If you're exposed to something really toxic, that's what your body would do to protect you from it. Allergy is built into our defense systems. There isn't a person in the world who wouldn't become allergic given enough toxicity. That's my view. What the genetics of allergy do is people who are genetically more susceptible will get the allergic protective response at levels of exposure that are not necessarily dangerous. It's just that they've gotten this hair trigger response. And for example, let's just take asthma in children. There is a gene for a protein, a detoxing protein called GST, or glutathione S-transferase. It's a really important detoxifier. And glutathione is a major protective substance. This allows you to use it to get rid of toxins. Children who have a defect in that gene are more susceptible to asthma, but only if they're also exposed to cigarette smoke or air pollution. And then vitamin C can really help them. Whereas for kids who have a normal GST gene, vitamin C doesn't help protect them. So that's an example of genetic susceptibility, toxicity, and nutrition interacting to determine what your needs are and how you're going to respond.
Kind of goes back to that old saying, the genes load the gun, but the environment pulls the trigger kind of thing with the susceptibility genes and so forth. It doesn't, absolutely. Just because you have the gene, it doesn't mean that you're going to be susceptible unless there's some environmental trigger, which is key. This has been amazing. You introduced a lot of new concepts. I love your book, by the way. The Allergy Solution is amazing. But let's finish off on the indoor air cleaning products and anti-smell type products. In taxi cabs and Ubers, there's all these and they're
such irritants. If you expose a laboratory rat to those fragrances, and they're all synthetic chemical fragrances, it produces inflammation in the lining of the nose. And the longer they're exposed, the greater the degree of inflammation. People who use cleaning products, sprayed cleaning products, they have an increased risk of asthma. In fact, respiratory therapists who are treating asthmatics in hospitals and in clinics, they develop asthma at a rate that is 4 times greater than the rate at which they had asthma once they start working as respiratory therapists. It's kind of crazy. Here they are, they're treating asthmatics, and the rate at which they get asthma goes up 400%. And so scientists have been trying to figure out, why is this happening? And they've related it to the use of all these aerosols that they're using to clean their equipment or the aerosolized equipment itself. This stuff is really very damaging to the lungs, and it sensitizes the lungs. So I'll just close with a statement on how difficult it is. In the book, there's this amazing study that my son Jonathan discovered from the University of Washington, where they looked at the air coming out of dryer vents. So if you clean your clothes with ordinary laundry detergent that's unscented, and then you dry it, the air that's coming out has hardly anything in it. It's just air. If you use a dryer sheet or a scented laundry detergent, what's coming out of that air is a real stew of chemicals, some of which are real irritants and allergens. And they're going into your backyard. Or if you walk down the street in New York City where I live, and apartment buildings have laundry rooms in the basement. And they vent them out to the street. And there's some apartment houses, you walk by there, it's like, whoa, I gotta go to the other side of the street because of what's coming out. The researcher that did that work at the University of Washington moved to Australia. And the reason she moved to Australia is that she couldn't get funding to continue her research in the US because the fragrance industry is so strong and so powerful. Wow. So, I mean, that's what we're up against. That's what we have to deal with. We have huge industrial interests that are making money by creating this by doing things that create this allergy epidemic.
And they're influencing scientific outcomes, or?
Well, they're influencing what money is available to do studies and the kind of publicity those studies get. I mean, you go, and the drug industry has the same kind of impact. I was interviewed a few years ago, maybe 10 years ago, on the Today Show about one of the topics I love to talk about, which is the natural treatment for heartburn and indigestion. And I discuss that in the book also, because it plays into the whole allergy issue in important ways. And and weight also, and the damaging effects of acid suppressing drugs on the body, which actually increase the incidence of allergy and contribute to weight gain. And when I was giving my presentation, as soon as I went to say something more than, well, these are the natural methods you can use to control heartburn, and to say, this is what's bad about these drugs, I was immediately cut off.
Wow. Not surprising.
Right. So, yes, right.
Yeah. Oh my gosh, it's too bad. Well, that's why we have this open platform on YouTube and Facebook and other channels to really get the truth out, which is amazing.
Right, it's so important to have that.
Yeah, and I like, when I read that study from University of Washington about the dryer vents and, causing toxicity and the 21 different chemicals I think she found, I was thinking about my own garden and where my dryer vent, and it literally goes right near the backyard, and I never thought about that, so I need to get that cleaned up. Not that we use, fragranted soaps and the dryer sheets, but still, maybe previous owners did, right? So, Dr. Galland, we have 3 final questions that we ask every guest on the show, and if there was one herb, nutrient, botanical, or whole food that you just couldn't live without, you're going to be stranded on a desert island, vitamin D and omega-3s are covered, what would it be and why?
You mean in addition to vitamin D and omega-3s?
Yeah, if you just had
okay, right, because you're eating fish and you have sunlight. It would probably be parsley. Because of the apigenin in it and what that does for you. Yeah, that's the herb. If I could grow something there, I'd want to grow parsley.
That's amazing. Awesome. And we know you're a very busy practitioner. You're on your 2nd book now, which is amazing. Fourth book. Okay, excuse me. So we want to know what you do the first couple hours of your day. What does that look like? You talk about meditation and being mindful. Talked about singing in your book as a way to help, de-stress. What does your morning look like?
Well, it depends on how much sleep I got the night before. I spend time with my family, with my wife. Okay. We really enjoy spending time together. Yeah. That is, I would say, the most nourishing thing that I can do.
Awesome. And I know that there's some research showing that in the morning people are more calm, so it's a little more quality time, would you say, than the evening?
Yeah.
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 Fantastic. That's great. And if you were to bump shoulders with President Barack Obama or a future president or someone from the World Health Organization, what would you want them to know about in like 30 or 60 seconds? What sort of
Well, I would definitely want them to understand what the fundamental thread of everything I talked about today, which is the interaction between toxicity and our health, and how the toxicity that we're creating is responsible for most of the health problems that we have. And it's impacting on the planet as a whole. 'Cause everything I talked about doesn't just impact human beings. It impacts the world in which we live and the future of that world.
Yeah. It's a big deal. Yeah. Well, thanks for sharing the great information.
Thanks.
Really appreciate you coming on the show.
I'm so glad that you did this.
Yeah, this was a lot of fun. Appreciate it.
Keep up your good work.
Thank you.